So this is all command line, black screen. So don't get scared, but it's quite simple. So I have a Kubernetes cluster. It shows 4-node cluster. And I show that I have Trident running here as a pod. Okay? And I have defined storage classes. I don't know why the screen is cut here, but it's basic and gold. So 2 storage classes have been defined. So I'm right now a developer, and I'm writing an application which is WordPress and MySQL. And you can see I'm defining a persistent volume claim and saying I need a MySQL disk, which should be of the type gold and should be this big. And I'm also defining a disk or creating a claim for a disk for WordPress. And then in my pod, I'm saying which application I want to run, in this case MySQL, and where the volume should be mounted. And I'm using the claim that I created. Okay. Same for my WordPress application. I'm creating a pod, defining which Docker image to use, and then I'm saying it should be mounted at this place and use this claim. So right now, there is no storage that has been provisioned. I, as a developer, is only defining what I need for this particular application and what kind of storage and how big. Now, you can just run this YAML like this in Kubernetes, and the application is actually deployed. And we can see that containers are getting created right now, both for MySQL and WordPress. And these are the PVCs, persistent volume claims, that the developer created for the 2 disks. And these are the disks that have been dynamically provisioned for this application on the go right now. So these already exist on a solid file system in this case, or any other storage system. So now we will just see, these are the services that we created, and I'm just going to see, OK, is my WordPress application actually running? So we'll just go and check that out. So it runs. And it's using and consuming storage, which was dynamically provisioned for the user. And he doesn't even need to know about it. So now we are actually looking at what the administrator setup is like. So the administrator is actually going to set up a backend. And it could be multiple different kinds of backend. So in this case, this is a solid file backend. And I'm already defining different types in this backend, which is gold, silver, bronze, depending on the quality of service levels I want. And then I'm in my storage class, I'm just saying, OK, this is the kind of storage I want to use here.
Do you have a way of limiting who gets what access to storage classes for the developer side? So that way, like, because every dev's going to want it to be in gold for whatever they're testing.
DevOps.
So,
is there a
sure, yeah.
Let me add to that so you can
Piece
answer
to
both. Let me add to that so you can answer both at once. I was going to ask, how about like quotas for those people? Where and how do you set that? Because otherwise, yeah, I'm going to want 1 million, and I want them all to be platinum.
So in Kubernetes, there is a concept of namespaces. So I can create a namespace for a particular development team. And then for that namespace, I can set quotas. So I can set quotas even on how much CPU is available to this team, how much memory is available, how much of the type gold storage is available to this team. So 1 TB of gold storage is available to this particular namespace, or number of volumes as well. So I can restrict on quotas and namespaces and define how much storage, how much CPU, how much memory is available to the teams. So that's possible already.
What if I want to change it from silver after it's created? If I go in the YAML file, change it to silver, does it talk to Trident and then say, oh, change the mapping on the back end?
So you will need to, so when we create these backends, we need to provide or execute them in Trident, right? So if today I have a backend and I'm defining these storage types, and then I change that, I think it will, or it will change it for the volumes which will be configured later, but I don't think it will update them for the older ones.
So you have to have a storage administrator go in and say, OK, downgrade that from gold to silver?
Yeah.
Yeah, so right now, Kubernetes doesn't have the ability to modify a PV, right? So things like size.
If Trident's,
class.
if Trident's your management plane, I mean, why couldn't it just go back and talk to the storage and say?
We need Kubernetes to be aware of those changes first, right? So if I go in and I change, right, I provision a 10 gigabyte volume, right?
Yeah,
I realize 10 isn't enough, let me bump it up to 100. You can absolutely go in on the back end and change that. The application will see that and be able to utilize it, particularly with NFS, right? But Kubernetes is unaware of that change. So it doesn't match up, and particularly if you have a recycle policy on the PVs, then it causes all kinds of havoc. So these are things that we are working upstream to introduce those storage concepts around, right? Not just the ability to do snapshots and clones, but also the ability to do things like resize, as well as, for lack of a better term, retier, right?
Yeah.
Seems like a new type of PVC that you could get them to, like a resize or a grow or a shrink or something.
So I won't feign to be smart enough to understand what's happening way down in the weeds at those levels or what the best architecture for those things happens to be, but I do know that we have some exceptionally smart people who are working on it. One of those happens to be sitting to my left. So it is something that I have confidence in, right? And the ability to eventually, right, work upstream, right, define those properties so that it's accessible, right? It simply becomes a feature set that's enabled.
But we don't want for devs to become storage admins, so there should be a limit in the granularity of features and capabilities that you want to show them. Otherwise, we will end up just shifting the issue from the storage admins to the dev level, and they don't want that.
Absolutely. So one of the core tenets that we have, that we operate with as an open ecosystems team is we're not working with storage admins. They don't care about, do I have deduplication, compression, compaction enabled? They don't even know what that is for the most part. I mean, yeah, you can figure out what deduplication and compression are just by the name. They just want to consume storage. So abstract all that away as much as possible. And frankly, it's not just the open ecosystems team that's looking at these things, right? NetApp as a whole is driving simplicity into all of our workflows, right? Things like System Manager on ONTAP now has provisioning templates and workflows. Where provisioning a VMware volume, for example, is now typing in the size and the number, and it applies the best practices automatically in the back end, right? And it'll even auto balance across aggregates if you ask it to.
So the advantage is, if you look at it from the other point of view, from another perspective, is that the storage admins still feel they are in control of their infrastructure. They don't feel like they are letting something go to the developers, but at the same time, the developers feel like they can play with the storage subsystem.
Correct. So I have my own soapbox that I like to get on, right, when I talk about these things. So, I've been a storage administrator, virtualization administrator for 15 plus years. The first time I created a VM, it was really cool. The 5th time, it was like, oh yeah, that's kind of neat. The 100th time, it was oh, this is all there is. The 1000th time, I just wanted to stab my eye, right? It's not fun. Provisioning a volume, regardless of the storage platform, is the same. If you're a storage administrator, where is the value that you're bringing back to your business? Is it in provisioning volumes, or is it ensuring that the storage empire is operating at peak efficiency? Right? Let's let the developers, let's let the application guys get the resources they need when they need them. And if it turns out that, let's take ONTAP for example, oh, I accidentally over-provisioned this aggregate as a storage administrator, right? I left them pointed at this aggregate for too long. Let me do a vol move and non-disruptively move them to something new. Right? So storage administrators can focus on big picture efficiency, big picture operations. Application administrators can focus on the application and just transparently consume. I keep using that word, right? Transparent, frictionless, seamless.
So what we just saw was a very, very simple application with WordPress and MySQL, but there are really complicated databases, for example, MongoDB, which needs to scale horizontally, for example, or create replica sets. So for those kinds of features, this is a new API or API object that has come into picture within Kubernetes to support different kinds of applications or databases which need different features which are not available today, or the existing concepts of deployment or replica sets that we have within Kubernetes are not good enough today to actually run these applications. So stateful set is a new feature, and why do we need stateful sets? Or there are a certain set of features that an application needs, then we can actually use stateful sets for those applications. So one of those is that your application needs to horizontally scale. So if we think about a database like MongoDB, which I can, when I'm scaling it with a concept of deployment in Kubernetes, what happens is when I create new instances of the database, it keeps mounting the same storage for me. But in case of MongoDB, when I'm scaling the database, I want new storage to be provisioned every time when I'm creating a new instance, right? When I'm starting the database, I might want to start one node after the other. So I want ordered deployment of my application, right? And then when I'm creating a replica set in case of MongoDB, I want the nodes to be able to talk to each other. Even if one node dies and starts on the other side, I want it to have a unique identifier so that one MongoDB 1 instance can talk to MongoDB 2, which is actually doing replication between each other. So unless they can talk to each other and have static IPs, for example, it's very difficult for them to actually do the replication. So these are the kind of challenges that existed, with which came out the stateful set kind of feature within OpenStack, which is very, very new. So this is a little bit more technical detail. How do you define a stateful set? Basically, you define a service. Like in case of MongoDB, if I have 3 instance MongoDB, I can reach my Mongo servers by saying mongo1.mongo or mongo2.mongo. So basically, kind of a DNS kind of service for my application. And then I define a stateful set in which I define the number of replicas. How many instances of MongoDB do I need? And then I define a template of how the persistent volume claims should be created for my application. So I'm not creating persistent volume claims myself as a developer. I'm creating a template so that Kubernetes can actually create those claims for me when I scale the database or create the database. Right? So now let's look at how we are defining that. So in this case, this is one YAML script or file. And on the left-hand side, I'm defining the stateful set. So the most important things to notice here is that I'm using the Mongo Docker image, so to say, and I'm defining how many replicas do I need for this application. On this side, I'm defining my service so that the services can talk to each other, like mongo1.mongo. All the instances can talk to each other, so I'm defining a headless service. And here, I'm defining a template. So every time a new Mongo node comes up, what kind of storage do I want to attach to this particular Mongo node? And I'm defining it should be read-write once, so only one node should be able to attach it, and it should be 100 gigs, and it should be of the type gold. So basically, as an application deployer, I'm defining all these things in the YAML, and now I can deploy it. So let's look at how we deploy it, and then how do we scale it.
Are you essentially building templates out of YAML files? Is what it's coming down to? And then you execute one of those templates to do a thing with some parameters? Is that really what you're...
So if I'm deploying, I know that I'm deploying a 3 replica set MongoDB, and I do not want to expand this cluster, I can just write one YAML file, which is standardized.
Yeah.
But in this case, I maybe want to scale, and I do not want to create a new YAML every time I need a new MongoDB, for example.
Right.
So that's when you actually define how you want your storage to be provisioned, and then that is actually dynamically done. So basically, scaling out your databases horizontally or creating more replicas is the basic concept around this. So, oops. So we will look at the YAML again, just to make sure what we are actually going to execute. So this is my YAML in my lab, and I'm defining the service for Mongo. It's called a headless service because it doesn't have any cluster IP. This is more technical terms in Kubernetes environment. And then we are defining the stateful set. Right, this is the stateful set. Its name is Mongo. So the service knows that I need to use the Mongo. It's already there. I'm defining the replicas. I'm telling it which containers are part of this deployment. So in this case, it's the Mongo deployment. I'm telling it what kind of command it needs to run, because MongoDB has different kinds of deployment. So I need to define, OK, this is a replica set kind of a deployment. So I'm defining that here. And then where these volumes should be mounted needs to be provided to it. So it should be mounted at data.db. And then there is another container which is available to actually create this cluster for MongoDB, which I'm using in this deployment, which is called Mongo Sidecar. And then this is the template. So I'm not creating persistent volume claims at the moment. I'm just defining a template as to how you will actually create the storage for this particular user. So now let's deploy this. So we are deploying it in the same way, just deploying the YAML file. And it created 2 things for me, a service and a stateful set. Now we will watch how this deployment is actually getting executed. So I'm saying kubectl get pods. And the important thing to notice here is I fast forwarded this, that every Mongo instance comes up one after the other. They're not coming up at the same time. So I don't see Mongo 0, Mongo 1, Mongo 2 coming up at the same time. Once Mongo 0 is running, then Mongo 1 comes up. So I want to have this ordered deployment, because otherwise I will not be able to create this cluster in a nice manner. So it took a while, and now all three are running. So now I have a running MongoDB instance with 3 replica set.
I love that you referred to 4 minutes as a while.
If we had to do this live and wait for it, yeah. So now let's see the PVCs that were created. So I didn't create any PVCs, I just created the template. So 3 PVCs were dynamically created for me by the stateful set. And then for these PVCs, which we can see they're bound, I have persistent volumes actually created for them. So they are all of the type gold, they are all 100 gigabytes, and they were created using the template, right? So there are 3 of them, basically.
So this is all pretty cool, but my legacy infrastructure mind and old school storage admin mind goes to spitting up all these instances. Great, right? I get the whole story, but how do you measure for performance issues? What's it look like? If I'm the storage guy and everyone's just spinning up Mongo databases, how do I troubleshoot noisy neighbor or just performance issues? I don't know if that's within scope of this conversation, but when I'm seeing all this, like, great, I can automate and stand up, all these instances, but my VMware days, remember when I let users spin up VMs as they wanted and then they stopped running very well, and I was stuck troubleshooting stuff as the storage guy. What does that look like? Is it just regular tools on the back end, or is that not a valid question for what we're covering here?
So this actual problem that you are specifying, so it's about the administrator losing a set of controls that he always had, right? So when I'm deploying, for example, a Mongo instance here, a Mongo image, I can actually define how much CPU and how much memory this particular container can consume. So I can restrict that. And on the storage side of things as well, if I'm using a storage system like SolidFire, I can restrict the IOPS limit for this particular user, and I'll also provide him with the guaranteed IOPS, right? So I'm losing control as an administrator, but I'm also empowering my developer to define and set the amount of CPU, amount of memory it can consume, so that I can manage different applications. Because if I have a platform like this where all my developers are actually jumping in and doing, we need things which we can control on the developer point of view, and not on the administrator. So we are giving more control to the application, but we are also giving them tools with which they can actually restrict themselves.
So you're hoping that the storage individual is ahead of time is setting QoS policies or whatever the SolidFire term is for that IO limits, whatever, ahead of time to make sure that, Nash only gets this amount of IOPS, Nick only gets amount of this IOPS. But what if, so that's the way of limiting that threshold, but how do you monitor to know that we need to maybe ratchet people down or make sure that these guys, even with the limits, if everybody's using all their limits, they could still start stepping on each other, because there's only so many resources in a given.
How many times have we been through this, right? VDI boot storms, leaving users to their own devices with giving them these gold, silver, bronze VM templates, and then just, here you go, guys, and then they just crush the storage.
Yeah, so I'll approach
this seems like another one of those.
Or even over-provisioning, right?
Yeah.
So I'll approach this from 3 different aspects. Right, so the first one is the application administrator, right? The guys who are actually deploying these things. How do I know that my application is doing what it's supposed to be doing, right? That doesn't change for them. They're still using whatever tools they happen to be using in order to monitor the application and the application's performance. The middle layer, right, which is the Kubernetes sort of host system layer, how much resources am I using? There's traditional Linux, Windows, host OS monitoring tools, right, both open and closed source, right? Absolutely, you can take advantage of those. And remember, the storage here is just a standard iSCSI LUN or NFS mount.
Right.
Which means that those tools can already look at that and determine the same sort of information that would historically be found in the VMware ecosystem, right, as a part of the performance charts that are there. So when we're talking about the NetApp portfolio, right, the storage administrator, if I'm running a SolidFire system, I really don't worry about it too much, right? That's the beauty of SolidFire, right? QoS policies that guarantee a minimum amount of IOPS as well as a maximum amount of IOPS. And for when those rogue developers write a terrible SQL query, write a burst, so we can chew through that query quickly and then trickle back down. Right, when we look at something like ONTAP, yeah, we recommend as a best practice that you create things like QoS policies proactively on the volumes, et cetera, but it is not an enforced thing at this point in time, right, for ONTAP or E-Series for that matter.
Are you working to build some visibility through this so that we can see which container instances are using how much IOPS, what volumes? If I've got a lot of things pointed to NFS mounts, I mean, we're finally at the point now with virtual machines where I can tell you which VM on which NFS data store is doing what, how much, when, and where. Yeah. And I think one of the big roadblocks to container deployments is we lose a lot of that visibility again. So, I mean, is there work being done to do that, or is that, you know, waiting on others? Or?
So in the broader ecosystem, I'm sure that that is being addressed. It is not something that we are participating at this point in time.
Okay.
So effectively, we're relying on those host-based tools, right, the Kubernetes cluster members, to be able to provide that information. As a storage administrator, right, we're able to look at things, kind of what I said before of, hey, this aggregate's getting hit really hard on ONTAP, let me do some vol moves, right? That's completely transparent to the application up above. Whereas with SolidFire, right, SolidFire is going to be just readjust the QoS policy as needed.
There's a few, I know for Docker container ecosystems, there's a few, like Shipyard and a couple of other that are the container management stuff.
Yeah.
They're getting a little bit of the visibility of the metrics of all of that stuff. But I think to Andrew's point, you're still managing storage, whether it's VMware or Kubernetes or whatever it is.
Yeah, I just see the storage guy getting yelled at again, right?
Yeah.
We kind of got through this, now we can trend,
Yeah.
now we can see, now it's a black box between this and that again.
Yeah.
Yeah, so hopefully, right, most of this, you want to have the mindset of a service provider, right? If I go to Amazon, if I go to AWS and say, I want this particular EBS, right, their SLA is this particular performance level. So ideally, theoretically, we're behaving as a service provider. We're simply ensuring that the SLA that we promised is being met, and then allow the application guys to work within those confines. Now, remember going back to the tenants, right, the thought process of DevOps, instead of Amazon where it's, well, I have a choice between 1,000, 1,000, or 1,000 IOPS, right? Well, I need 10,000, so I need 10 volumes, and I'm going to stripe across it. Maybe go talk to the storage guy and say, hey guys, 1,000 IOPS ain't cutting it. Can I get a platinum tier that's 10,000 IOPS? Something like that, right? Working with the teams, working across, right, vertical integration in order to, I know across and vertical doesn't make sense, right? But working across those, right, in order to, again, achieve what's best for the application, ultimately the business.
So you were talking a bit ago about like changing size of the volume, things like that, having Kubernetes reread the config and that. What about changing IOPS? Like you're saying, if I change my QoS policy, does Kubernetes care at that point? Does it need to read the config, have issues with it, or is that totally transparent?
So it would be completely transparent. So in particular, if we're talking about storage classes, so I've defined a storage class Gold. Gold is SolidFire with this QoS policy. It's on top with this disk type, for example. Right? If I go in the back and I do a vol move in ONTAP, I change the QoS policy in SolidFire, whatever that happens to be, Kubernetes has no knowledge of that. Even if you change the size of the volume, it's not going to break anything. It's just not going to know about it.
Okay. So I'm thinking like from a YAML perspective, like if I change from Gold, I need to redeploy at that point.
Probably we need new API objects like retyping a volume.
Right.
Right.
And that's where I was going with it, is being able to change it on that side without tearing my app down at this, being able to basically not live move it to a different tier.
Yes, ideally that would be what we would love to see, right? This is the same principle
It's not
that we've seen in
right now,
VMware.
though.
Yeah, it's
Correct.
Today we have more or less only provisioning capabilities that we
Exactly.
see.
Okay.
It's not to the extent we can resize, retype volumes.
That's
today,
fair. Okay.
So the whole point here is that we can scale our database with a single command. So the part that was missing, or the part that we are going to at the end, is where we actually say kubectl scale my stateful set to number of replicas to 5. So I can do that by just typing a command. So this is very, very powerful, I think, in my opinion, that you could do something like this, which was, I don't think it is possible today with such ease that you can do something like this. Just giving a simple command to scale your database, like you can scale your stateless applications. So that's what stateful sets brings to the picture. Should we just let it run or skip it?
Go ahead.
Yeah. All right.